Hey everyone, am I audible? Okay. Yeah, so with Chaosian, we are building an accountability protocol for the agentic economy. So the problems we are focused on is, of course, around the foundational problems of trust in AI systems. Of course, like we have centralized AI models and stuff like that, but then we want to also enable agentic economies, and there is a trust gap, right? So we are looking at few primitives in chaos chain, like for the blockchain, of course, like Ethereum is the kind of like global settlement layer. And then ERC-804, I hope everyone is aware of ERC-804. It provides three registries: identity, validation, and reputation. So this basically allows us to do two things. One is like provide intent verification, so which basically means like we can give proof of authorization to our client agent. So whatever our intent is, for example, if my intent is to find winter jacket, my client agent is going to prepare an intent mandate, have it cryptographically verifiable, so that then when it's interacting with a server agent who is going to execute on that task, the server agent is aware that this really came from the authorized person or authorized user. User could be also an agent, right? Another primitive is the payments protocol, X402. This basically, it's an amazing unlock for agents, because like agents no longer have to, like go through the user interface of creating accounts and then getting API keys and stuff like that. So this enables like machine-to-machine payments in a seamless fashion. So agent can just do payment required, and then like with that they can get paid, and then also get the services across. Now, we are, so with these three primitives, we are building the accountability engine. And then at the base, we, of course, have these three standards. And we enable like end-to-end verifiability workflows. And this we will do it through studios. Basically, with Chaosian's SDK, you right now can get access to this triple verified stack. So you start by layer one, which is the intent mandates. So it sits more or less at the user interface, right? So human to the client agent, or again, like the user can be an agent to agent as well. So you have the intent, that's the first stack. Second is Chaosian's process integrity stack. So here, basically, we will be looking into the internal mechanics of an agent, so that we have verifiable execution and secure execution. So we have also like done integration with Eigen Compute, which is of course like in early developments. It's not that scalable, but you can of course like use any other TE solution or like ZK-based solution for process integrity. So we also like I think the simplest one would be just to hash the code of the agent and then see if you can verify it later. Another aspect of process integrity is verifiable claims, because an agent can make a lot of claims, like I run the best model or best data set, I have access to like specific like API tools and so on and so forth, but we need to verify those so that like, there is no, so that everything is trustless. Also, these things should get tied to agent's reputation. So for example, if my agent is using Eigen Compute to run inside it, so how good of a service provider Eigen is, this should be visible in the reputation of this agent over time. So all of this is getting hooked to the reputation registry of 804 for each agent. Now, third is the core thing about Chaos Chain, that's the accountability protocol. So of course, like the whole protocol is still not ready, but you can get the gist of it with our current SDK. Now, when the full protocol will be ready, we will be basically performing causal audit on the whole workflow of agent, which allows us to basically zoom into the chain of work of when multiple agents are collaborating with each other. And causal analysis basically helps us to figure out what specific cause leads to what effect. And based on that, we can work on a fine-grained score vector. Then that basically completes the feedback loop. Now, so Studio model, like you can think of Studio like an app store, but not for static apps, but for autonomous services. So the goal is to have niche-specific studios. So you can create like a Oracle studio or a winter jacket studio or a gaming studio. It could be broken down into a much more specific use case. So what a studio will do is basically set a global context to all the agents that will be participating into it. And why is this important? because we want to keep fine-tuning the context for each agent so that like we can optimize their performance. Now so Genesis Studio is just a simple example that you can like try out as an initial version of a studio model using Questions SDK. So yeah, this is more or less the workflow. Like client agent will send a request, and then you have the agent execution with the process proof, and everything gets packaged into an evidence, which then our verifier agents will be auditing it based on this package. And the final record is used to build the ERC804 reputation of worker agents or server agents. Yeah, so this is fine. Now, yeah, like you can try out this, like we have Python and TypeScript SDK to try to build a triple verified stack for these agents. So you can build, again, you can take a look at the Genesis Studio file. You can run it to understand the fundamentals of this SDK and Genesis Studio. And based on that, you can like try out building different studios or marketplaces. Now, the base install for Questions SDK, what you get out of the box is access to 804. So your agent will instantly get registered. You can select a network. So right now, again, you can check where we have deployed. It's Ethereum, Sepolia, Base, Optimism, 0G, and also BNB testnet. So you can register your agents with 804 on those chains, and then out of the box, of course, like you can set up the paywall server for your agent to get paid using X402. And then have storage access locally on IPFS, or you can also use Pinata service, which is inside the SDK. And then we have like some more integrations for different compute providers. Like we have 0G compute integration and also Eigen compute, which you can try out, of course. And same with the storage. We have 0G storage and IPFS. Yeah, any questions? Yes, sir. You need some mic.
It's working. Okay. Very basic question. You guys have a booth here. I was not able to find you guys here. Where are you?
Yeah, so we are in the lobby. So yeah, you can just like find us in the center of this hall outside.
Look for Chaos Engine.
Never mind. So
okay.
yeah.
Okay, that's the reason. Okay.
Yeah. Yeah. I will be there.
Hi, sorry. I came in a little late, so can you like summarize really quickly in 30 seconds maybe like what the 3 steps do, like what each one represents? Like you're talking about verifiability, right? So yeah, please.
Yeah, so like Questions triple verified stack basically like starts from the intent verification. So that's more or less at the UI, right? At the user interface between you as a user or agent as a user to your client agent. So like let's say your intent is to find the best winter jacket. So your client agent will create an intent mandate of it. So we use Google's AP2. You can of course like try other ways to create intent mandates. And then, but with our SDK, like you can easily use Google's AP2. So this intent mandate using JWT, we cryptographically encrypt it, and then that becomes a proof of authorization. So now your server agent, with whom your client agent is, like let's call client agent Charlie, and Alice is the server agent who is going to, like help Charlie with finding the best winter jacket. So then Alice now has a kind of has a proof and an assurance that this is coming from an authorized user, and it's and Charlie is not going to like fool Alice into like spending resources unnecessarily. So like that's the layer one of the stack. And second is the process integrity. So in second, basically, we try to have verifiable execution of the agent and have verifiable claims of the agent. So because you want secure and verifiable execution, right, of the agent logic. So the process integrity is all about like internal mechanics of an agent. So we have integrations with integration with Eigencompute and also like zero-G compute. But both of them are like TE-based solutions. You can of course try other solutions here to integrate with triple verified stack. So for now we have these integrations already, but that's another playground to experiment with. You can like look into ZK or like any other watermarking techniques, for example, for LLMs and stuff like that, how you can have verifiable claims for an agent. Another thing to look into is Chainlink's runtime environment. So this CRE, which is also like for short CRE, CRE could be used, I think, for making verifiable tool calling of an agent. So that's worth exploring as well. And then in the third, basically, like Kyoshin's accountability side, this is where like we have verified agents. So verified agents, let's just consider one. We call it Bob. So Bob basically will be like looking at Alice's work and validating it. So this is the simplest version. The more complex version of this would be, Bob basically will be performing causal analysis of Alice's work. So that basically that helps in figuring out like a better score vector and what cause of Alice is going to lead to what effect. And that basically helps us provide a much more better way to score this performance of the agent.
Okay, so the layer 2, basically you decide like what method to use. You were talking about
Sorry?
The layer 2, it's about what's the code executed right. So you mentioned that something with zero-G.
Yeah, so zero-G has, zero-G compute is basically, they also have a network of TEs. You can use that. They also have storage, like a decentralized storage, so an alternative to IPFS. Also, like the goal in process integrity is to not have any vendor lock-in and have different providers to exist in this ecosystem. And the thing is, like, so let's say my agent chooses zero-G compute and yours chooses Eigencompute, okay, for running in a verifiable way.
Okay, circuits.
Ah, nice.
So they abstract everything for you. They generate the verifier contract. You can even deploy it. But the thing is that you cannot have these two big contracts in blockchain. So it's been like investigated, but it's like complete verifiability. So you can check if the answer was really like coming from the model.
Yeah.
So I think that is like more secure.
Yeah, for sure. Yeah, like like TEs, I feel like they're like just a partial solution and temporary solution. Like in the long term, or the ultimate goal is to have ZK proofs for verifiability, right? Like starting from the model itself, from neural nets itself. So there are like different techniques, of course, researchers are exploring. And yeah, it would be great if you can like try it out. And we, of course, want to, in this process integrity, we want to adopt ZK. ZK's best like processors and stuff like that. But I haven't like yet done it. So if you can like show that, that would be great.
Thank you.
Mm-hmm. Okay. Any more questions or? All right. So I will be at Nethermind booth. So come find me if there is any more questions or doubts or anything. Yeah. Good luck.